In recent years, fiber optic laser cutting machines have become the driving force behind the global production of sheet metal parts. The growing variety of products and smaller machines have forced manufacturers to move away from traditional methods of profiling with dies in favor of this modern fiber laser technology. Modern laser cutters enable very high cutting performance while maintaining the ability to cut single parts and small or large batches without having to invest in expensive equipment. Unlike the older generation of CO2 lasers, fiber lasers consume much less energy, and thanks to the shorter wavelengths, the laser beam can be focused to a smaller diameter, which allows for faster cutting speeds. Today, we will see what solutions Polish manufacturer KIMLA are producing with this fiber technology. The heart of the machine is the laser source. The optical fiber is pumped utilizing high-power laser diodes, stimulating the active medium to generate laser light by the optical fiber. The laser beam is fed to the cutting head, also using a flexible optical fiber, which eliminates the need for mirrors and beam paths to distribute the beam known from previous lasers. Most manufacturers of laser cutters use control systems used primarily in much slower cutting machines, wasting the potential of the fiber laser. They need to slow down to overcome complex shapes to avoid deformation. KIMLA developed a control system dedicated to high dynamics to take full advantage of the physical properties that fiber laser offer. Once the drive system had been designed, the focus shifted to developing the right drives. They need to be durable enough to handle high dynamics and cutting speeds. KIMLA uses linear drives that operate without contact, different from the technology that utilizes mechanical drives that can wear out and require periodic replacement. Here, the axis movement is driven by a magnetic field that cannot wear. Eliminating these gears provides greater efficiency of the drives. Also, the energy used to accelerate the axis is recovered during braking. The recovered energy is transferred to the accelerating axis. The result? Energy consumption to power drives is reduced by 70%. Linear motors, however, are relatively heavy, resulting in reduced acceleration. That is why KIMLA researched the use of modern magnetic materials with high saturation induction for use in new generation drives. As a result, linear drives were created and implemented for production, in which the power was increased 3 times without increasing the weight of the drive. The use of a suitable machine body was significant to achieving cutting precision. Monolithic frames are used in KIMLA laser cutters, which are rigid, stable, and do not require a foundation. Dedicated milling machines large enough to be able to machine the laser body in one are used in the KIMLA factory. The ease of use of the device is also essential. Until now, lasers were programmed by an external CAM system, and any modifications required the involvement of a programmer who had to generate a new NC code or program. KIMLA has created a solution in which CAD, CAM, and nesting functions have been integrated into the control system. Thanks to this, you can work without an additional programmer, because all the preparatory work can be done directly by the operator. KIMLA lasers use many innovative solutions that have facilitated the increase in cutting performance several times while maintaining high precision and keeping operating costs low. KIMLA lasers can be equipped with many options to increase efficiency and functionality. Printers for detailed descriptions, tube and profile cutting systems, as well as loading and unloading directly from the automatic sheet storage rack, allow you to adapt the configuration to meet your needs.